It'll all be good. So it says, what is the sign of the angle that has a terminal side of this? Now, remember, terminal side just means it stops. Terminal side is where the angle stops. So it says you have an angle. What is the sign of this angle that has the terminal side of this? What do you notice about this XY point? Where does it come from? It's a familiar, very familiar point to us. What point is it from? Colton is saying that this is an XY point on the unit circle. Do you agree? I agree. You say, oh, this is on the unit circle. Well, cool. Now, I had somebody last hour say, well, that's 150 degrees on the unit circle. He had it memorized. I'm like, yeah, that is all fine and dandy. True. Yes, you're awesome. However, did we even need to know that? No, it said, what's the sign? Well, this is an XY point. What do we know on the unit circle about XY points? If it's on the unit circle, what do we know? Cosine is that? No, sine is, no, cosine is x, right? Cosine is x, and then sine is y, and then what is tangent? Yeah, good. Tangent, way to remember that. Tangent is our y value divided by our x value. Okay, so what is literally the answer here? Yes, root 3 over 2. You just said it yourself. Sine is the y value. So it says, what is the sine of this angle? You would say root 3 over 2. It's really that easy, but you have to know what it's asking. So hopefully helping you out. So some of you might get, what is the cosine? You would have said -1/2, true? If it said, what is the tangent? You would have taken this divided by this. You would have had to flip the second and multiply. Okay, awesome. Next one, write down the problems from start to end. There will be a lot of open-ended questions, and the algorithm in their computer can tell if you've done it right. So it says, create a cubic equation with imaginary roots. So you will have to, from start to end, be able to do this, and it will be different than the person next to you. It will be able to tell if your answer is right. So first of all, create a cubic equation with imaginary roots. What do we know about cubic? What degree is that? So it's degree 3. Okay, so good. It's degree 3. And then it says it has imaginary roots. Now, roots are solutions. So I have a question for you. If you have degree 3, well, how many solutions will you for sure have? 3. So if I have degree 10, how many solutions should I have? 10. That's called the fundamental theorem of algebra. You'll see that on your final exam. So we have x equals something, x equals something, and x equals something if we have 3 roots. Now it says it wants imaginary roots. Can anyone tell me a rule that we have learned this year about imaginary roots? Anything? Oh, yeah, you're on the right track, Colin. Yes. Yeah, true. So here you're pointing out where i's come from. Good point. But, so you just pointed it out correctly. He just said if 3i is a solution, what else has to be a solution? -3i. Conjugate, and if you have an imaginary solution, its conjugate has to be a solution. I'm going to use not 3i just because that's big. So that's not bad. I'm going to use I. Isn't that a solution? It's imaginary. So what else has to be a solution? -I. Now guess what the average Joe will do next? They will then go to the third solution and say, well, it says we need imaginary solutions, so I'm going to, yeah, I don't know, 2i works. Does it? Why do you say no? Because then what? So you're saying then you would need -2i? And now what degree is it? 4. That is not possible to have 3 imaginaries. You can have 2 because they come in conjugate pairs. It is not possible to have 3 imaginaries. So what's another solution we could use? Sure. Isn't 0 okay? Does 0 have a conjugate pair? What about 1? Would 1 work? Yeah, 1 doesn't have a conjugate pair. Any number will work, people, except for a square root of 3 or a square root of 2, because that also has a conjugate pair. So we would say x equals, I don't know, 0 or 1. I'm going to go with 1. So now we have to work backwards. You would want to put it in standard form. Do we remember how to work backwards? Good. We got to get it equal to 0. You're right. So we would have an x minus I equals 0. Then we would add I. So we have x plus I equals 0. Right here we'd subtract 1, subtract 1. So we have x minus 1 equals 0. Now what would we do? Put them in parentheses and multiply them together. You're awesome. So now, remember, when multiplying 3 things together, you should multiply 2 together. Combine like terms. Multiply in the third. What 2 things would be smart to multiply together? The i's, the conjugates for sure. We're going to focus right here, multiply those together. So let's do it. X times x. X squared plus ix. True? Now the next one, wouldn't that be? Minus ix. Okay. And then negative I times positive I. Negative I squared. So now we should combine like terms. Don't the middle terms cancel out? That's what happens with conjugates. So we have x squared minus I squared. Can that simplify? What is I squared? So you're saying this is x squared minus, and this is negative 1? True. So that is x squared plus 1. Now think about why that makes sense. If you set that equal to 0 and solve, you would subtract 1, you'd square root it, you just took the square root of a negative, which is what Colton was saying. Does everybody see? So we have x squared plus 1, and now don't we need to take and multiply x minus 1 in? So you guys finished distributing that. Ready, go. Put it in standard form. Okay, what is the final answer here? Did you get that? That's what I just heard someone say. Okay, cool. Moving on to the next one. Now look, it makes sense. There's a cubic equation. We had our 2 imaginary roots and then 1 real root. Awesome. Okay. Now let's do this one. So it says, given negative x to the 4th plus 10x minus 3, it wants to know, as x is approaching infinity, where is f of x approaching? And as x is approaching negative infinity, where's f of x approaching? So write that down. As you're writing that down, just a reminder, this is dealing with end behavior. This is one of the very first lessons of the year, really. End behavior, what's happening at the very left and very right, the very extremes of the graph. So in words, we would be able to describe where this is going for the end behavior. So can anyone remember by chance the rule, or where we looked, or anything? No, but good try. Yes, people. Colton, thank you. Colton has been pretty much the only one up here helping me out. Everybody else, focus. I feel like half of you are just sitting there and not caring on purpose or something. We look at the front term. We look at the degree. It is even. What do we know about evens degrees? And behavior. So you're saying it could go up and up or down and down. Evens have the same end behavior, everybody. Then you look at the front. Is it a positive or a negative? It's a negative, so isn't that a frown? Down and down is our end behavior. Let's say you were desperate. You would type it into your calculator and look at it with your eyeballs. Well, let's hope that you're able to do it without. So it goes down, and yeah, it's not a quadratic, but we're just looking at the left and right, so it doesn't matter. So in words, the end behavior is down and down. That's one way to describe end behavior. This is the more formal way of describing end behavior. So what do we know? As x goes to infinity, where's f of x going to? Negative infinity. As x goes to negative infinity, where's your function going to? Also negative infinity, which makes sense, down and down. Just a different way of writing it. This is 2 different ways of writing end behavior. Down and then that's another way of writing down and down, just more formally. Okay, do not forget those. We should not be missing those. Those ones were not super advanced ones. Let's go to today's lesson. So as you get out 12-2, I'm going to remind you of what we learned for 12-1 because we're going to need some of that information again. So it's on 12-1. 12-2 is stapled to 12-1. So last time with 12-1, we were dealing with measures of central tendency. So what does that mean? Wasn't that just looking at things that tend to be in the middle of the data set? Measures of central tendency, things that tend to be in the center of the data, which was our mean, which is average, median, which is the true middle. Median is the true middle of the road. A median is the true middle of a data set. And then the mode was what happens most frequently. A reminder, mode is most. If you have one mode, all is good. If you have two modes, all is good. But if you have three modes, there is no mode, right? Okay, because that's just too many. It's all affecting the data the same. Then we also talked about spread of data, which was range. So how things are spread out was our range. So now if I have a 2-year-old and an 8-year-old, my kids are spread over 8 years. Does everybody see how that makes sense? I don't have any kids, but I'm just saying. If I have a 2-year-old and 8-year-old, I have it's spread out over 8 years. 2 and 10 would be spread over 8 years. You do 10 minus 2, the largest minus the smallest, right? So, oh, am I saying 8? In my head, I'm saying 10. Sorry. 8 and 2 is 6, so that would be spread over 6 years if I'm saying 8. Okay, awesome. So, questions on range. Okay, awesome. Remember we were able to find all that except for mode in our calculator. So we're going to need to use our calculator again. So we're going to go into 12-2, which is talking about spread of data, but in more detail. So this is called standard deviation. It's more with spread, and I'll explain. So standard deviation is a measure of how far the numbers in a data set deviate away from the mean. Now remember what mean means. Mean means average. So I'm going to read that one more time. Standard deviation is a measure of how far the rest of the data deviates away from the average, away from the mean. So I'm going to kind of give you a representation visually here of that. So let's say I have a data set of numbers. I'm not going to actually put numbers. Let's just say I have some numbers up here written. I can go through and find the average, correct? I would add them up if those were numbers and divide it by 4. So I can find the average. Now remember, average doesn't fall necessarily directly in the middle, but it's towards the center. So let's just say that's our average. Some number is our average. Now look at that. All of these points, these numbers that are here, will deviate away from the mean. Right here, aren't these ones close to the mean? Aren't these ones a little bit further away from the average? And the further we go out, the more spread out away from the average we are. That's what standard deviation is, and you'll see how it works in a second. Now, if you're not given the standard deviation, your calculator can calculate it for you. So this is how they write it shorthanded. Sigma is just saying find the standard deviation. Just like X bar means mean, sigma means standard deviation. So I would probably make myself a note of that because I might just say find sigma, and you have to know that that means standard deviation. So it's just a quicker way of writing standard deviation. Now variance is just that sigma squared. Sigma is spelled like that, S-I-G-M-A, if you're curious to what I'm saying. That's just a quicker way of writing it, like I said. Variance we will not use in this class. It is used in statistics, but we won't use it in this class. However, it will ask you what the variance is. So all you have to do is take your standard deviation and square it. So let's say my standard deviation was 2. The variance would be 2 squared, which is 4. And we're not going to use variance for anything, but it will ask you that. We will use standard deviation though. So let me show you how standard deviation works. We could do it with a formula, but this is not a statistics class, so we're going to just use our calculator. So it says right here, what are the mean, variance, and standard deviation of these data values? So I'm going to show you how to find it in your calculator. So grab your calculator, and it's going to be the same way that we did it last time. So everybody hit stat. Then go into edit. Then in list 1, you need to put in the data set, which is this. Once you have done that, you'll hit Stat, go over to Calculate, just like we did last time, and then the one variable statistics. Hit Enter, just like we did last time. There's nothing different. So it gives you X bar, which is our mean, which is our average, which is what it asked us. We need that. What's our average of this data set? Sorry, say it louder. 69.8. Let's just go with 8. 69.8. Everybody agree? Did you all get it? Okay, cool. And then our standard deviation. So I'm going to show you where that is at on your calculator. Some of you might be already seeing it. I already have mine typed in, so it'll be quick. Yeah. So right there, do you see how a sigma? It says we, of the data set, our mean for X is 69.8, and our standard deviation is 10.7, everybody. You see that? Pretty easy. So then, standard deviation, we write like this. Standard deviation is 10.7 or 6, I already forgot. Thanks. And then now we would, to find our variance, because it's asking us to, we would get out, just completely get out of there. And so hit exit and hit 10.7 squared, because variance is sigma squared. 10.7 squared is what? Okay, cool. Everybody good with that? Easy peasy. So now how do we use that? I'm about to show you. I want to point out something. So our average is between in here somewhere, right? Which did split it evenly-ish. Okay, here we go. So let me show you how standard deviation works. So it says right here, in a data list, every value falls within, in some data lists, every value falls within some number of standard deviations away from the mean. For example, if the mean is 50 and the standard deviation is 10, then values between 40 and 60 would be within one standard deviation from the mean. So let me show you how I map it out, okay? This is just a way for me to keep track of what we're looking at. So we're told the mean is 50, so our average is 50. I kind of go and put a circle around it right there. Now, from there, our standard deviation we were told is 10. So let's go one standard deviation above. Wouldn't that put me at 60? What's one standard deviation below? 40. So any value that falls in here or here would fall within one standard deviation from the mean. So if I said to you, 43 is within how many standard deviations away from the mean? You would say 1. Do you see how that works? If I said to you, how many standard deviations away from the mean is 60? You would say 1. It is included. That is included in. Okay, let's go 2 standard deviations. So add that standard deviation again. That would be 70. So, oh, I said 1, but I meant 2 standard deviations. So then that would be 30. So if I said to you, within how many standard deviations does 65 fall? You would say 2 standard deviations away from the mean. And we can continue to go out more and more. Does everybody see? Okay, so think about it. The more standard deviations out we go, the more spread out the data. True? The bigger the standard deviation, the more spread out the data, because it's obviously stretching out if the standard deviation is larger. So here's the thing, the less spread out the data is really the better. You would rather have a data set that's not really random and super spread out, it's all close together. Then it has reliable statistics. Okay, so this is how it's going to word it on your homework. So I would just watch this one, I wouldn't even take notes. It says, grab your calculator if you need it. It says within how many standard deviations does all of the data fall? So it says the mean length of Beethoven's 9 symphonies is 37. So I'm going to start there, circle that. It says that the standard deviation is 12 minutes. So let's draw out this little thing for ourselves. 37 plus 12. Let's go 2 standard deviations. Let's go, for kicks and giggles, 3 standard deviations. Yeah, this didn't feel right for a second. 1 below. Okay, cool. 2 below. 2 standard deviations below. 13, and then 3 standard deviations below. 1 minute. Okay, cool. So now it says, within how many standard deviations do all of these symphonies of this length fall? Meaning, how spread out is the data? So 27 minutes falls within which standard deviation? 1. True. 30 falls within which one? 1 standard deviation. So these are all close to the average. 47 up here. 35 falls down here, right? 30 falls within here. Aren't these all close to the average? That's good. The less standard deviations out, the better. So these all have fallen within 1 standard deviation. 40 is still here. 35 is once again here. 22. It's 2 standard deviations away from the mean. Good. 65. Oh, it's clear out here to the 3rd standard deviation. So this is what the spread looks like. So how many standard deviations did it take to entrap all of the data? 3. It took 3 standard deviations to get all the data. All of the data fell within 3 standard deviations from the mean. Do we see what I'm saying? So our answer would be 3 standard deviations. I always have people wanting to add up these. It's not. This is 1 standard deviation. 2, 3. It took 3 standard deviations to entrap all the data. True. Here is a fact for you. You need to write this down. What is officially mathematically an outlier? I'm going to tell you. So this is talking about spread. We know outliers are extremes. By mathematical definition, an outlier is anything outside of 2 standard deviations. So an outlier is 3 standard deviations or more away from the mean. Anything within 2 standard deviations is not an outlier. So there's a lot of times where I have given students a data set and said, which one's the outlier? And they looked at it just with their eyes and said, none, there's no outliers, because nothing stood out enough to them. What they should have done was found the standard deviation, done the mean, and went out and made sure nothing fell within the 3rd standard deviation, because there's something that is far enough out, it's considered an outlier. Does that make sense? So this is how you know which one's officially an outlier. So what's the outlier? 65, correct? Okay, cool. Yes. Oftentimes, yes. Otherwise, we would do list 1, type it into our calculator like we did on this one. Because you see how we could go through and answer that same question here. Okay, do we need another? Okay, so this is important. A low standard deviation means that the data is very closely related to the average. Thus, it's reliable. So a statistician will often they'll do this out and make sure that there is a low standard deviation so that it's not so huge that if they go and take the information to the company, it's not accurate. They're going to lose their job, you know, because they're going to figure out in the next year if that guy's statistics were accurate. So they want to make sure that it's actually reliable. If it's all spread out all over the place, they better not start doing all the statistics and making general conclusions. It's too spread out. A high standard deviation means that there's a large variation between the data and the statistical averages, thus not as reliable. The smaller standard deviation, the better. So if I ask you this, there's a data set with a standard deviation of 10. There's a data set with a standard deviation of 6. Which one's more reliable? 6, because it's not so spread out. Does that make sense? Standard deviation is lower. Okay, cool. Do you need another example of how many standard deviations does all the data fall? You guys understood it with the little chart I did? Okay, cool. I'm not going to waste your time. Finish 12-2.